10:15 a.m. presentation, apply automation to increase quality and speed to market. Edward Jaeck is Vice President of Strategic Growth and Business Development at Lowell. He has a 6 Sigma Black Belt and has been certified to the ASME GD&T standard at the senior level. He utilized a hybrid strategic policy deployment plan for brand makeover and enabled several key Lowell developments, including a new best-in-class dimensional inspection laboratory, machine automation, and Monte Carlo-based cost modeling. Mr. Jaeck also worked for Medtronic in Santa Rosa, California, and Intel in Chandler, Arizona, in R&D, materials, design quality, and supplier quality. Mr. Jaeck has a bachelor's degree in mechanical engineering, a master's degree in industrial engineering, and a master's degree in engineering management. And so I just want to let you all know, part of this presentation today will include a demo with Q&A towards the end. And so I just wanted you to be aware of that, so please stick around. And without further ado, please help me welcome Edward Jaeck.
Thank you. So this is the A team. Thank you for coming. Today we're going to talk about automation and the applications of the automation to the design verification, design freeze, design validation, as well as any process validations you need to do. So as mentioned, some of my background was at Intel. I taught Jump, I taught design experiments, and Jump scripting. So if you've used Jump software, you can script. It's not as easy as Minitab, right? You got to do some macros in Minitab to get the data automation where you need to be. You need a different skill set. Currently at Lowell. Lowell's a privately owned contract manufacturer for precision titanium components. We specialize in the assembly of mating components. It's kind of one of our fun niches, is understanding how the tolerances need to change on the joint to get you the functional requirement. 55 years in business, privately held, and it's a great place to work. So appreciate my team and support team and my management team's support over the years to get to this. So there's 3 key aspects as you go into a new project, right? The marketing team is going to do the customer needs, and then you're going to do your flow down, and you're going to get into the aspects. So looking at it from the perspective of design, is anybody here in design or R&D? 1, 2. How about marketing? Okay. Supply chain or purchasing? Okay. And then general management? Great. Okay, so you're all going to have a role to play in today's fictitious scenario. So the first thing is you've got to define your test, right? So what I saw done fairly well at Medtronic was beginning with the end in mind, as Stephen Covey talks about. You have to look at your architectural plan, your product performance spec, and usually those things start out huge, right? And 143 requirements that have to get validated and knocked down. But somebody's got to really architect that out as to each one of these things. What are we going to do to get to this, all of those things passing, right? And it's easy to just think positively, but until you actually work that all the way down and put it to paper in the summary table in Excel, it can be very abstract. Secondly, you got to do the visual assessments. What kind of data analysis do we need to do? What kind of sampling do we need to do? And I love this photo because I have a 10-year-old and a 12-year-old, and this is my definition for a highly capable parking process when my 12-year-old starts driving. I don't want them anywhere near the sidewalls in the garage, right? And that's great until you got to put the second car in the garage, right? So once you've done number 1 and 2, we've really thought about what success looks like, what the visuals look like, what the data submission package looks like. Then you're ready to actually go automate it, right? And automate it helps with data integrity, it helps streamline, and quite frankly, once from the management team, you've been collecting DV data or PQ data for weeks, right? And the tests are going on. But once that rumor gets out that the last test is done, they get anxious. They want to see the summary report. Did we pass or did we fail? But we're going to show you today. You can have that information by the end of the day. Within half hour, I can tell you whether you passed your validation. Up to 200 columns of data. success, clearly, you cannot overemphasize it enough to the design teams, right? Because great or successful design engineers, they really understand the user needs, and that's forced with the flow down to the requirements. But then there's this cost function, right? And everybody on the supply chain side and the buying and the purchasing side feels that, right? I had a mentor explain it to me once at Intel. It only takes one stupid feature to take a commodity component into a sole source trick component. And anybody that spent time in sourcing, it only takes one feature on a drawing with bad tolerance that no one in the world can make. And now you're into a single source or a sole source situation. So then there's the cost, and then there's the validation considerations. So what you look at on the left, these are boat anchors. You can go to YouTube. One's a Coke can, one's a coffee cup can of Folgers, and then the big one is a 5-gallon bucket. So if we're designing a boat anchor for the rowboat in my pond, I just need a mast. So think about it from a design perspective and a validation perspective. What are we validating here? It's an object with a mast, and it has a bolt, an eye bolt, that has to not shear. So maybe it's mass of the object and a shear of the bolt. Well, if you're in a river, you may need a different anchor to keep you from moving, right? So now you look at this and say, okay, well, what are the critical features on this anchor? I'm sure whoever designed this probably has a ratio of this triangle for teeth and grabbing as the function, and that's probably a function of the length of that tooth and that angle, and then how much that boat anchor will pivot. That determines how well it bites into the riverbed, right? You wouldn't necessarily use this in a pond because it's light. It may not have enough mass, but it will keep you from drifting in a boat. So there are different considerations, and a great design engineer understands all three of these and is optimizing them simultaneously. If you do one, you leave out the other two. Right? And that's always the challenge for everybody around the design team, is to keep reminding them of the simultaneous boundary conditions. So my analogy is to help that process along. Anybody know what this looks like? Anybody been to Japan? This looks like a pachinko machine. So a pachinko machine, you drop a ball on the top, and the ball bounces through the post, and then it lands. So I call this my critical feature pachinko machine. So there's a little spot for critical, there's a bigger spot for major, a bigger spot yet for minor, and then the negligible column is big. Why is that? Because as part of the management team, I don't want my design engineer calling everything critical. This is a Me Too product, it's a follow-on product. You can't have 30 critical features, right? We don't have the time or the budget to go validate 30 test methods to measure that. I want everything in a negligible bucket, and maybe I'll give you 2 critical, because we don't have the time or the money. So what happens is you come up with this design rule, it's a guide, to minimize the ratio of A to B, right? The critical features to the negligible features. So it's a simple ratio. We'll move it to Excel, right? So you want, how do you minimize this? You put the minimum in the numerator, and you maximize the denominator. So in a table form, if you start in row 1 with design 1, let's say there's 10 features on your part. One of them has been labeled critical, 2 major, 3 minor, 4 negligible. They sum to 10. Critical over negligible is 0.25. So you have these ratios. And this should be your design review. Anybody in the management team sitting in on your design reviews, this is what you should be grading your design team on. And you can't have 10 critical features on the part. And for everyone that is, you should be justifying why it is. Right? So as you move your minor features in row 2 to the negligible, this ratio goes down. Right? So as an analogy, what you can think about is, if you're familiar with regression, you can do a forwards regression. And this is the way I like to do it in design reviews. If you, my design team, could only have 1 critical feature out of the 10, which one would you pick? And why? You only get 1. So form your team, form your committee, and tell me which one and why, and justify. Then you send the team in from the other side. The analogy is a sinking balloon, where the balloon's crashing or everything, they're throwing sandbags off. This one starts, as most of us probably, where they're calling every feature critical. And now you're the person in the room trying to get rid of a feature and downplay it. And there's people that are paranoid of, oh, we can't have that not critical. So the second way to run the design review is to put everything as critical and then punt features off until there's 1 left. And then what you do is you compare those two teams, you should get the same feature. If you started with none, which would be the first one, if you started with all of them critical and removed one at a time, which would you end up with, right? And this is a spec justification document. Somewhere in your process, I'm sure somebody's doing something similar to that to justify what and its clinical relevance. Right, so the graphic here just points out that you should end up with the same critical features. So at a device level, in a bone screw, it may be clamping power or holding power, right? And then at the component level, you should flow that down into what is clamp force a function of at a dimensional level. Right, so you build the table, and as you can see here, you're moving the majors and the minors over to the negligible. You have your built-in dashboard. Design one is the worst because it has a higher A to B ratio. And the last one's the best because you have one critical feature. And most importantly, you've moved all of them to the negligible column. I want everything negligible. If you come to Lowell and you give me a drawing that has critical features, I gotta validate the critical features. So we're spending money, you're spending money, to either develop the test method and then run the parts and measure the parts. There's a lot of money in NRE that goes into this, right? You want one feature measured. You don't want to measure 30 features on the part. So quick example, you take basic kind of a wheel for my kids' roller derby, but you know, you can look at drawings, I'm fluid in drawings from the GD&T perspective, so I don't get easily overwhelmed by drawings, but a lot of people do. But at first glance, there's a lot going on. But when you zoom out and you just focus on the critical features that are labeled, some of you may use notation for critical, major, minor. It's always a good thing to do on a drawing. It really boils down to some very simple features. It's got a thickness, it's got an OD, it's got an ID, and then you have to locate that ID to a datum structure, which is the bottom of the part, and the OD. So it's a positional feature, right? You're drawing it, you're assuming it's concentric. But if you don't control it to a datum structure, I can put that hole anywhere on the part, right? So you simplify it, you bring it in, it's in English units, 250 plus or minus 5, and now the fun work starts, right? So now you move it to the table. This again, we're in the section of define stuff clearly. I've taken your drawing, design engineer, you have an OD, an ID, a true position, work position, and a thickness. But now I've got to pass the gauge on R for all 4 of those, right? And then I got to pass a validation success criteria for all 4 of those, right? And the wording that I like to see is 95 confidence, 95 or 90% coverage. I think in this industry we're unique that most of us, and is anybody here in a 95 range for confidence and reliability? Really? Packaging? Yeah. Packaging is the toughest one, right? Because of the risks from the biocompatibility leading to allergic reaction triggering to death, right? But most folks in the orthopedic should be 95, 90, right? So now, when you put it together, 4 basic dimensions require 4 test methods and 4 passing criteria, right? That's 8 things you've put on the table, and if one of them fails, you fail. You go back to the drawing board and you fix it. Well, now let's say there's 3 functional requirements on top of the dimensional requirements. And this is where the design teams often don't think it through, right? Because if you come in with a functional requirement that says that washer or this hub has to assemble correctly, and the answer is an attribute, yes or no, technically, you should be doing an attribute agreement study, right, with a cap of greater than 75%, which is the equivalent of a continuous gauge on R, right? So this comes in, if you're in the doctor's office, I've been there where we've passed an entire validation, and the validation failed because the doctor answered that they couldn't see the device from the radio passivity because they were never trained with an attribute agreement study of how much is visible enough, right? So they seem easy, but if you don't take them to ground, they can get very complex. So washer assembled correctly, yes, no, pass, fail. Technically, you need to do the equivalent of a gauge on R on that with good parts, bad parts, and marginal parts. Right? Second one, does the washer fit snugly in its feature? Yes, no, again, you're into attribute sample, right? So now you've got 3 more test methods, and these are vaguer than the relatively easy dimensional ones. And now you have the same confidence reliability for the validation. So once you have some attribute things here, your sample size is already n equals 29 equals 0, So any hopes of doing a low sample size based on the dimensional, they're gone. You're into any 29 super zero. Right? So now you put it all together, you've got 7 here, 7 here, they all have to pass on the first round. Anybody here do project management who's in the PMP office? Right? You guys get it. How many loops are you planning in your validation? 2, 3, or 1? Right? We don't have time for a second one. And everybody's overconfident that they're gonna pass the first time. But if no one's taking this stuff to ground to prepare, the probability of you passing the first time is probably 20%. Right? I'd love to talk to you afterwards and see what your actual first time pass rate is. It's a great KPI for an organization. That's 14-0, right? That's going 14-0 on the first time around. That's pretty impressive. It can do it, but a team needs to be thinking it through. So the visual assessment, shifting gears a little bit. Hopefully that becomes a visual assessment for you. In your next design review here, take that away. When you're looking at 30 critical features in your product performance spec, think about this with the test methods and then the validations. The complexity will grow on you. So in a visual assessment, this is a great thing. Has anybody seen the movie Cars? Right? So Cars was inspired from northern Arizona. So Peach Springs is an actual town in northern Arizona. This is I-40, Flagstaff would be over on the right, Kingman's over here. And it's a beautiful drive if you ever get in the area. I suggest you do it. But they built I-40 through here, and the minute they did, they cut off Peach Springs. And when they made the movie, the guy drove, this is old Route 66. So overnight, Peach Springs went from a busy town where everyone's driving through on 66 to it's in the middle of nowhere, and now it's just a tourist attraction. So I call it a bypass. People still do it. And we all make that decision every day when you're on the freeway and it's backed up. Do I get off here and take a surface street? Or do I sit here and then get backed up for an hour and I can't get off because there's no exits? That's a good lead in, because as the data architect for your validation strategy, you want to build in a bypass. I'm going to talk about that in detail. So here you get off I-40, you get on the surface street, you come back onto the freeway up here. The bypass that we're going to build is what I call the continuous to attribute sample size bypass. You start up top. Has anybody here done a validation plan? Okay, so you've done a validation plan. So you've got, let's say, 100 things that you're validating. For each one, you have to define, am I going attribute or am I going continuous? Right, so you're gonna make that decision here on this B level. Variable data is coming down this path, attributes over here. Attributes easy. If you're at a 95-90 in this orthopedic, 29 samples, if they all pass, you pass, you're done. Right, but you're into pass-fail data. Once you go down to the variables data collection, this gets a whole lot trickier, right? Because now you've got normality you got to test for, and you've got to calculate sample size for every feature independently, and then you have to pass that, and eventually you're going to fail one of those things, and then your quality engineers come in, or your statisticians come in, and people that don't know what they're talking about come in, and things get bogged down in the mud. Right? So what I encourage you to do is to do 29 samples for your validation, because if your continuous data gets bogged down in analysis paralysis, if your data's in spec, you pass. And this is supported by Dr. Wayne Taylor's book on statistical procedures for the medical device industry. If you have not bought it, I highly encourage you to buy it. He consults to the FDA. And his fallback is an attribute sampling plan is always accepted. If you want to talk more in detail about that afterwards, I can give you more details on that. But what it basically says is don't get greedy trying to calculate sample sizes for the lower sample size for variable. Just do n equals 30 or 29 for everything. And you can run your data analysis. It's great to know. But if you get bogged down in the mud and it's in spec, you're passing. And the validation is going to move forward. The project guys, you love that. Go figure that data analysis afterwards. Go play with that all you want. All I need to know is that am I keeping the schedule or am I not keeping the schedule? So as an example, here's what happens. Technically, what you should be doing out of an OQ is you take your OQ, you calculate your mean standard deviation. This is real data. You could do this in Minitab. You go into Minitab, you take these two numbers, pre-summarized data, go into the confidence and reliability, and you calculate the sample size needed to demonstrate 95-90. What happens is you get different sample sizes for each feature. So for this one, you get 5. right? But what happens is you can't run normality on n equals 5. So somebody's in your design area saying, oh, 5's not enough, we gotta round up. We gotta round up to 9. Then somebody else comes in and says, oh, you're at 9 and 12 for these two? Well, you know, they're both less than 15, and we can't run the skewness and kurtosis check, which is the third check in normality, in case Anderson, Darling, and Ryan Joyner fail. I can't run that with less than 15. You gotta round your sample size up. So here as a design engineer, a validation engineer, there's pressure from the cost folks, from design budget and the project management team to keep costs down. So you're trying to run as many sample sizes as possible, and everybody else, the conservative people, are rounding you up, right? So now you get to 20, because you need 20 to do any analysis of variance. If anybody wants to compare PQ lot 1 to PQ lot 2 to PQ lot 3, which is a way of checking for stability, you gotta have 20 of Minitab. So now you went from 7 or 5, now I'm rounded up to 20 for everything. Okay, so now I'm up to 20, and I get to the true position. This is actually interesting data. So you take the data from the OQ, and this one tells you 28. So now the biggest number out of all of them is 28. So now I'm rounding all the way up, all of them, I'm rounding them all up to 28. Well, guess what? Your actual sample size is one more, is 29. So just go ahead and make it 29, because you're gonna thank me later when I save you with a deviation on the validation, because it's all in spec. And then finally, the last person that comes in is great. I love this person. Well, to run the proper capability analysis for the PPAP process, you have to have n equals 100 to run the capability analysis. So now we have 3 lots in the PQ, and you need 33, 33, and 34. So you know what, that 29, we're gonna actually round that up now. Now it's up to 34. Because we've got to meet some other criteria in the process. Right, so that's great. This data set, you don't have to read the chart. It's huge. This is your drawing with 30-something features on it. So whoever the lucky analysis person is, does anybody run Minitab to run these validations? It's an extremely fun process. Column by column, you step through Minitab, you start doing the analysis, and then you copy and paste it to a report, right? So data formatting is key, right? But for each one of these, what I want to see from my visual summary as management is I want you to do a box plot with the spec limit up top. I want you to run an outlier test, got to make sure there's no outliers. Here's your Anderson-Darling test. Here's your Ryan Joyner test for bin data. This is very, very common for chunky data or bin data. And technically, if you fail the Anderson-Darling test, but you see bin data, which looks like this as vertical lines, means that you have inadequate measurement resolution, right? And as your resolution of your metrology gets worse, this is what you start to see. Guess what? If you have poor resolution, you can't treat yourself, you can't treat the data as normal, and you can't do a variable sampling plan. I've been in situations where we thought about it, we didn't have enough resolution of the data, we have to treat the data as attribute, we didn't have enough sample size. Guess what? Loop number 2 on the validation, because you underpowered your sample size. Then you run into the tolerance interval calculation, right? But in Minitab, this only goes out to 3 decimal places. So now you gotta go to the session window to pull the data out of the session window to get the data you need for your summary report. And then finally, the capability, right? This is the big thing, the PPAP or anything like that. So you're doing this manual, column by column, and somebody's stepping through this. It's ripe with errors, and it's ripe with data integrity issues, because technically somebody should be checking that as you go through, make sure the data's been transferred correctly. So great, we just did 1 column. This probably will take you half hour to 2 hours to do what we did there to crunch through that. But now you got 17 more columns. Right? So that's mundane. Everybody would agree if you have to do this data analysis, it's mundane. By column 6, you don't even know where you are in the data set anymore. You're zoomed out. And then you realize that's why my dad asked me to go push mow the yard when you're 12 years old, because you're out of the house for now 6 hours rather than an hour, right? And it's great, but it's not great when your suppliers are charging you NRE to do data analysis, because that's focused on time at a burn rate of $100 to $200 an hour. It adds up. Then you got to take all of that and you got to build your summary imaging. So this is just a basic Excel summary. how many data points in a lot, how many outside the spec, is the entire 9590 within your spec limit, and then what's your capability. But you're building that cell by cell because you got to copy and paste if you do it the traditional way. So what we figured out is I went to the Minitab Insights Conference last year in Arizona. They have another one coming up this year in Virginia. I highly recommend it. They had kind of had a macro boot camp there. And we've been working on this for a while, but I said, this is ridiculous. We got to automate this. There's a better way to do this, right? So we have a macro that we call PQ it, which is great because I can tell Jack, one of our engineers, just go PQ it. Send it through the macro, hit go, and it'll analyze your data. So what the macro does, it basically takes all of your data columns in one fell swoop, and it just runs it through the macro. Builds a box plot, builds an outlier test, runs the Anderson-Darling test, runs the Ryan Joyner, and it builds your process capability. And it does that for each column. And then it just steps through and does the next column. And then it dumps it out into PowerPoint, it dumps it out into Word, and it builds a summary table. So now you're no longer cutting and pasting anything. It's coming right out of this into Word or into PowerPoint. It then builds you this table here, which is a little bit of an eye chart, but you have your box plot here, and then your number out of spec. If you see from a project manager, if I see 0 out of spec, and I powered at N equals 29, we're done. This thing's moving forward. This is all fun data analysis on the right-hand side, continuous wise, but this is your money slide right here. 29, 0 failures, next thing's going to the next step. Some of the tests we programmed in was the skewness and kurtosis check. By the way, this feature is not in Minitab. We've programmed it into the macro to put it into Minitab. And you use the skewness kurtosis check for the third check on normality. When I was at Medtronic, if you failed the Ryan Joyner test, you had to email a corporate statistician, and then they ran a custom Excel file from Dr. Taylor to tell you whether or not you could treat your data as normal. And that took 2 days to wait on the statistician to get back to you, right? And then there's another table we create that gives you a PPK. And again, this goes out to 200 columns. If I have 200 columns of data, 200 features, it's analyzing all at once and it's done in 15 minutes. And then the last one is answering the comments interval with the spec. So the key point is what used to take 8 hours, 16 hours, 30 hours a week for data analysis on validations, we've compressed it to 15 minutes, right? Which from a lead time and a project management schedule is ridiculously fast. If you're doing a lot of validations at a corporation, I estimate this is a $250,000 a year savings at any company that does validations. Design freeze, design verification. If you're doing MPI and you're not doing this, you're burning a lot of money that you don't need to. Right, so now you come back after the macro and you see the appreciation for the table that we just built is automated, with this functionality, and we don't have to build it cell by cell. Okay, so in summary, we talked about defining success. Right? You take it down to we simplify the design first. You have to do that. Minimize the number of critical features. Then you got to build that validation plan with the bypass. The bypass is the N equals 29, C equals 0, the attribute sampling plan. It's cheap. If you go to 95, you're at 59, C equals 0. It's a nonlinear curve. We sit at the sweet spot using it, right? And if you go to 95.99, it's 2.99, right? Those, I wouldn't recommend this. But at 29, that's cheap. You're paying one way or the other, right? You create the visual assessments. What do we want? Let's take the data. How's it going to flow through? Think that through, put it on an architectural map. And then you finish up with, okay, now that we know what we want, write the macro. Hire it out, write the macro. You're doing these things over and over and over again. So that's the data animation in the R&D or the new product development. Why are you sending teams with brute force to attack something that you do every year? It's ridiculous. But you have to be doing the same analysis to justify the macro expense, right? We do a lot of the same analysis, a very basic analysis, but you do it over and over and over again for each customer, right? So simplify it and then automate it. Thank you. We're going to shift gears into an actual demo of the Minitab. So Jack, if you could bring up the Minitab. While he's doing that, if anybody has questions, great, thank you. If anybody has questions on this, you can raise your hand. One that I'll start it off, validation. Somebody's always going to ask about validation. So validation is easy because you're in the macro language, you're invoking Minitab commands. So you're validating back to Minitab. So whatever company you work, you guys have validated Minitab, right? So any macro work that your team does, you just gotta go back to Minitab and run it through the capability analysis and get the same number. So the validation is simple to do, you just gotta run some checks, because you're not modifying the Minitab code. You're invoking in a series of commands. Okay, so what you do in the macro is, the macro comes in as, it's basically a GUI that comes in up top. So Jaeck will go locate the file, he'll open the file, and then he'll run the script, and that brings that Excel dashboard in. And what you have to do, we built a special Excel dashboard with the tolerance limits up top, right? So what you see is the lower spec limit and the upper spec limit built into the dashboard. So now you bring it in, and he'll look at the number of columns, and then I'll say, okay, let's go do our data review. Jaeck, if you could, let's run the analysis and build the PowerPoint. And what we'll do with the PowerPoint is we're gonna step through and make sure there's no funky data. Right? And we can do this, we've done design reviews in 15 minutes. It's ridiculously fast, because it builds it for you. And then once you're fluid in the data of what you're looking for, you're just looking for funky data. And if it's not funky data, it's passing a malady. You're using all the canned calculations from the session window. You're done, right? So the fun thing here is, it's like watching grass grow. We just saved you, 100 hours of work, but it's still not fast enough when you're watching it, right? So it'll run for each column of data, it's running the same series in the macro, and then it's gonna output it to PowerPoint in presentation-worthy format that you can cut and paste and present to a boss as a final validation report. And again, it's not gonna be 100%. There may be some columns of data that, for example, are log normal or exponential, that you gotta go back to and do special analysis. So this will run for a couple more seconds. It clicks an arrow, PowerPoint's launched. We delete a couple summary slides, and now we're ready for a step and repeat. So, looks good, no funky data. I passed the Ryan Joyner test, so greater than 0.1, it's normal. I can use my normal analysis. So here, PPK 1.0, it's normal, that's fine. You put it in the summary table, compare it to the customer, whatever the validation requirements are. Next feature, same thing, nothing outlier, fun box plot, less than normality, so I failed 2 normality tests. But now I'm gonna get to this point and say, I don't care. So this is the beautiful thing with Dr. Taylor's textbook. I don't care, because now I'm gonna invoke his 3rd rule in his flowchart. This is a highly capable process. I don't need normality. I'm done, I'm moving forward, right? Getting good at the rules of the game that come from Dr. Taylor to the FDA is a key thing to accelerate the product development. If you get bogged down and you don't know the rules you're playing against, you're gonna get bogged down, you're gonna have an argument here, well, we can't use this because it failed normality. Yeah, but it's also a highly capable process. It's more than 2 times the capability requirement. We're done, we're moving on. Try that in your next data review and see how well that goes. And unless your project manager is pushing it, you may run into some problems. So now you just step and repeat, right? And this will do this for 100 columns, 200 columns of data. This makes your design reviews very simple, because it's just you're stepping through. Jack, let's go back to the session report in Minitab. So, what your internal statisticians, what your professors have always taught us is, forget about the formal statistical tools, graph your analysis, look at your data, right? Be one with the data and understand your data. So that's why I take you through the PowerPoint first, because you're looking through the data, and if there's an outlier, you maybe run the analysis with the outlier, without the outlier, you tease it out. But if everything looks good, you're done. Now you come back to your session table, and you just cut and paste, and you're into your validation report. You're done. Right? Send me a data set of 100 columns of data. I'll have a validation report back to you by the end of the day. Project management guys, you love that. Because how long on average do you wait now? 2 weeks, 3 weeks? And then everybody has to weigh in on it and approve it in Agile? And then there's people that are more conservative and less conservative? This eliminates 90% of that. So here's your summary table. So, in summary, define what you want, learn how to do macros, and automate. And anywhere in your organization, when you're doing validations, whether it's design freeze, design verification, design validation, or any of the validations you're doing at your suppliers or internal, you just cut out 90% of the work with better data integrity and less errors. because you're not typing anything in manually. You do it once on your tolerance sheet, and the tab handles the rest. We'll leave it there, and we'll bring it back. Anybody have any questions? No questions? I get to ask questions. Project management team, what do you love about this?
Well, it's the speed and the reporting. And if everything's right there at my fingertips, at least 2 weeks of savings.
Yeah. Is anybody doing macros now in their organization for Minitab? No. So from Bill, from a supplier PPAP initiative, could you see the value in this as you streamline this with the supplier just sends you their data in this format, and somebody at Zimmer just hits the poof button? Yeah. Now they're not analyzing it differently than you're analyzing it, right? You streamline that.
That file that you're uploading to Minitab, is that a manual entry or is that the output of other measurements and stuff?
Usually it's a combination, right? So we do a lot of electronic movement. So that is a compilation because you're bringing data in. So it could be the combination of the QC Calc, electronic merger. It could be hand data that you're bringing in from a caliper, right? Depending on how you get that data. So that's where the labor is. And that's where you need to be checking data integrity, right? And that can be easily done with a graph built in Excel to check for a typo or something like that. So you do have to put in a little bit of data into that Excel file with the spec limits. That takes a day. You check it, you build your visual indicators to make sure there's no funky data in that. And then it's got to be in that same format for the macro to read it correctly. But once you build the infrastructure, it's step and repeat, step and repeat. Any one of you can send me data tonight if I give you that Excel file, and I would have a report for you within 3 hours. I don't care how many columns it is, as long as it's under 200. Macro just crunches it, sends it to PowerPoint, and we would have a design review talking about your process, centered, not centered, shifted, normal, not normal. Is it multiple stream? Is what it is. Management team, what do you like about the macro? Who raised their hand on the management team? Would this help in management reviews or design reviews? Right? The teams are doing, it's called standard work. Every design review now is being done with the same table, same summary. People are getting familiar with it. Obviously, there's stakeholder management, that people get the chance to weigh in on what your macro would look like. You customize it for what you need in your organization. But now it's the same thing. And it covers 90% of the work. There's always a couple of things you have to do some ad hoc data analysis on, but that's the exception, rather than doing ad hoc one at a time analysis of 200 columns of data. Any other questions? Thank you.
Thank you, Edward. If anyone has any questions or any further questions, Edward is happy to stay and talk with you. Also, if you would fill out your evals and drop them here at the back table, I'd be greatly appreciative.